Hey y'all, Data Guy here. And today, kind of building on the back of my previous video going over, how to get set up with Pinecone, I wanted to also make a video because started off this channel about Airflow and I'm still all about Airflow. So today, what we're going to go through is how you can use Airflow to create a machine learning pipeline with Pinecone. So what I'll show you is kind of two different ways of taking your data, vectorizing it, then embedding it, or then loading it into a Pinecone index. One is going to be really simple, and one is going to be a lot cooler, and was created by my colleague Tamara. And there'll definitely be a full video on the Astronomer channel that you should check out later. But I wanted to make this video quick to get the word out that now Pinecone is compatible with Airflow. So if you're running the latest version of Airflow, you can now use the Pinecone. Let me actually, before I go into that, so here you can go to your requirements and add your Airflow, Apache Airflow provider's Pinecone, and then we'll also be using scikit-learn and OpenAI pin to 0.28 because that is the last time that they had the vettings place work that Tamara worked on. Again, that's why tune into Astronomer when we have the full video because it will be much more thorough and actual workable. And then to kind of just give you a preview of what we'll be building here before we get started building it. So here we have the Pinecone example DAG, and here you have a import data function, so bringing in your data, in this case just from a local file, vectorizing it, then getting the vector dimensions, creating an index if it doesn't exist, and a Pinecone ingest operator. So here, actually I'm going to trigger this DAG, and Pinecone example DAG. Apologies, I got it mixed up. So that was actually the Tamara version. So this is the simple version. So we just have a start, empty operator, create an index, convert our data to a Pinecone format, ingest that as vectors into Pinecone using the new Pinecone ingest operator, then querying Pinecone and deleting the Pinecone index. So here, if we go now to the code, we can start building. And so outside of needing to set up your requirements file with these three packages, just make sure you're running the Astra runtime 9.5. And if you're not running Astra CLI, you should run the Astra CLI. And then here, let's build pineconeml.py. And so here at the top, we will need to import quite a few different packages. So first, JSON, because interacting with Pinecone, it basically is all, even the Python or SDK or the official operator, it's all leveraging that API. So you need to make sure that you have a plan, in my case, JSON, to actually take that API request information because it will be returned in a JSON format and turn it into something usable for you. Then classic pendulum date time, empty operator just to start, airflow test and DAG decorators. Then we have the Pinecone ingest operator, and then also there's the Pinecone hook. So it's a little bit hidden in the official documentation, but it is there. And so here's a hook that you can use to interact with Pinecone, just as if you were in there firing off the commands through the API. Then we also have the sklearn tfidif vectorizer. So this is an open source free vectorizer that you can feed your text into and it will vectorize your data. So super useful tool so you don't have to figure out how to vectorize yourself. And then we also have our regular expressions, and this is just giving us the ability to read in certain regular expressions when we're generating a unique identifier. Then finally UUID, because we're going to need to create unique IDs for each of our movies that we're going to be analyzing. And I almost forgot. So the end result of this, we will have some movies that we will take in, read their sentiment, find out, hey, these movies are about sci-fi, this one's about romance, and then allow us to search that movie data and say, hey, I want to find a movie similar to this. And in this case, I'm going to show you just how to do it with plain vectors, but you could also, vectorize your query and then use that to query the database. So, and that's what I'll show you in tomorrow's example. So after we're done with our basics here, we're going to our package imports. We'll set a name for the index. So our name for the index will be just test index, and then we have normal DAG declaration, Pinecone example DAG T, because I have zero creativity, and then setting our file path. Actually, we should set our file path up here. So setting our file path, then setting a start empty operator just so it doesn't begin by just allows us to trigger more functions. Then having the generate UUID function we're going to create. And so what this will do is just take the information around the movie data and use it for what the movie title is and generate a unique identifier out of it. Then we also have our get vector dimensions. And so what this will do is just read the length of our data after we have vectorized it and get us the dimensions so we can create an index with the right size of dimensions. And so your dimensions are how many vectors there are for each ID. So for these movies, you'll see there's about 100, 150 vectors for each movie. And so it's just an easy way to do that dynamically after they've been generated. And then we will have yet another function, and this is just going to be the import data function here. And so here what we're doing is just importing data from, again, our local file path that contains this movie data, and then going through here, splitting it into the different categories, title, year, and then vectorizing all of these different data points. So you can see here to append, movie ID, title, year, genre, description, and then feeding those into the vectorizer fit transform, and then enumerating them because not only does Pinecone require you to vectorize your data before you upload it, but you also have to make sure that it's in the format of ID and vectors, so you can't have like different. I guess you can use metadata for kind of categorizing it, but it's otherwise kind of tough to figure out what these vectors represent. In my opinion, at least. I mean, maybe I'm just missing something. Then after return data, vector data, import data function, include movie data, get vector dimensions from movie data. So just calling that function and then including it so we get the vector dimensions ready. And the reason we need those vector dimensions is so that we can create an index out of them. So here you can see we are creating a new index just out of using the Pinecone hook. So here the Pinecone hook, both the hook and the insert operator both use the connection management UI. So you can do a con ID for the Pinecone hook, and then use after you initialize the hook to create index with dimensions and the name for the index. Then I'm going to set another, or we're going to just initialize that task by just feeding it the vector size. So here. And then the next thing we'll have is converting it to Pinecone format. So data conversion, using that function we created earlier to create it or convert it to Pinecone format. And then using the Pinecone ingest operator, we can ingest all of that good old data into Pinecone. And so you can see that happening here, task ID, connection ID, index name, the input vectors that are resulting from that data conversion task. And then finally, what we can do here is define a query for Pinecone. And so here, this is where you'd probably want to take your query and vectorize before. I was just testing this out really quickly. So what I did was just take, directly from the data that we vectorized, use that for the query. So it should, in theory, return me just the result of the first movie that we vectorized, and then print the query response. And then what we can do is query task. So query Pinecone with the vector data from data conversion. So again, just setting it, giving the data it needs to use it as its own query to make sure we get a response. But you'll see that actually didn't work. Wink, wink, nudge, nudge. And then down here, what I'm also doing is just a handy dandy delete Pinecone index that I am setting as a teardown task. So no matter what, even if my index fails, if I'm done querying it, just delete it so I don't have to delete it manually myself, because every time you create an index on the starter plane, you then have to delete it if you want to create another one. So humble plea to Pinecone, please allow us to create multiple indexes on the starter plan. And then that is really all we have to do on this side of things. So after we're done with that, what we can do is go into our DAGs or our Airflow UI after you've done AstroDev Start. Go to your connections menu, and here you're going to want to set your host, which is going to be, if I go create index here, just create it really quickly. So you can see your host is going to be printed out here. Your project ID will be these 6 letters up here for a connection. So host, project ID, Pinecone environment, you can just find that right here. And then your API key, you will pull from your API key console over here. and then boom, you have a connection to Pinecone. Really pretty simple to set up. And then what can happen here is, see, I want to trigger that DAG. Oh, it's going to fail actually because I just created that stupid index. But you can see I actually ran it before, where you can see create index doesn't return a value, convert to Pinecone format. And you can see the IDs here. If I actually go to the details menu, you can see in the render template, you can see the movie ID, and then you can see, the title, linguist. So then it gets converted to the Pinecone format, and we can see that being as a XCOM of here. So here, really large XCOM, converting it to Pinecone format, sending it into via the Taskflow API into our Pinecone vector ingest operator, where here you can see successfully ingesting that data to our Pinecone index and then querying it. And you'll see here, I get no matches because I didn't upload enough data. So my follow-up video to this, and I realize it's going to take its own video because it's already over 10 minutes long, where I'll show you how you can use OpenAI and online databases to actually upload enough data to get meaningful queries. But if you follow this format and upload your own data as long as it's of enough size, maybe don't make it as complex as I did. In terms of, like, maybe just upload like, hey, a bunch of CSVs of customer responses and say find me the most angry customer. Things like that probably be a better use case, and it just is able to query your data really fast. So stay in tune for a follow-up video if you like this and you're interested in more, but you should have enough to go out there and start playing around with it. So hope you enjoyed this video. If you have any complaints, any comments, let me know in the comments below. I'm always listening to you. And above all else, have a good one. Data Guy out.